we're very excited today to have Stacy Downs presenting with us. She is our resident transformer condition monitoring expert, years of experience in engineering that will be able to guide us through the breather. We also have with us Josh Hertz. He's one of our principal engineers. He'll be with us as well, talking about helping out with any other engineering type questions. So without further ado, I would love to hand it over to Stacy so she can take us away.
All right. Hello, everyone. Good morning. Today we're going to be talking about some devastating effects of moisture on a transformer and why a breather is so important to a transformer. We're going to be talking about smart transformer breather technology versus a traditional transformer breather. What are the differences? What are some of the advantages of a smart breather? And then we're also going to be discussing how this kind of fits into a condition-based monitoring approach and how a smart breather can save you money in the long run. So let's get started. So what are some of the effects of moisture on a transformer? Water, even in the smallest quantities, can be harmful to power equipment. Generally, it's attracted to the places of greatest electrical stress inside of a transformer. It accelerates the deterioration of the insulation oil and as well as the paper inside of the transformer. So over time, as water builds up in the transformer, it can quickly accelerate that loss of life over time and degrade the insulation properties of the oil, reducing the kV factor as well as the paper insulation. Once that insulation is degraded, it loses the mechanical strength, and you can't return that to the original condition unless you refurbish that transformer. So you don't want that to happen. Water inside of a transformer obviously impedes the performance as well as shortens the lifetime of that asset. There's multiple ways that you can get moisture inside of your transformer. There's the two main categories are atmospheric, and that's really what the breather is going to aim to solve, and we'll talk about that in a few minutes. But atmospheric moisture can come through many different ways, but the general ways that it can get inside of the transformer are through leaks in the equipment. So anytime you have bad gaskets, seals, cracked insulation, anywhere where oil can leak out, you need to assume that water can get in. So that is definitely a way that water can be introduced into your asset is through the atmosphere. Another major category is through internal sources. So as you know, paper starts to degrade, the oil starts to degrade. One of the side effects is that you get more moisture building up inside of the transformer, which just enhances the problem. So another problem in the internal sources is also wet insulation, and this is really temperature dependent. So as your asset, your transformer is under normal operation, the load changes, the temperature changes, the water inside of your transformer is constantly in flux between the oil and the insulation. So it's constantly moving back and forth between the two, which is also going to shorten the life of your transformer over time. So internal and external sources of moisture are a big problem inside of an asset, and you want to eliminate or reduce those as much as you can over the lifetime of your asset to ensure that long, healthy life and no power outages or anything like that. So what is a transformer breather? A transformer breather is a device that's designed to prevent the normal moisture from the air or the atmosphere from coming in contact with the bladder or oil in a transformer. You can see up at the upper right-hand part of the drawing, you'll see the breather hanging there on the conservator tank. So the way that a breather works is as the oil cools down and its volume is lowered, so as your transformer is either under less load or the temperature drops, the oil is going to the level of oil is going to be lowered, and that is called an inhale phase of the transformer because the transformer is going to pull in air from the atmosphere through that breather that you see again up in the upper right-hand side of your slide here. And as that incoming air from the atmosphere travels through the breather, it's going to remove the moisture because there's moisture in the air. Depending on what climate you are and what region of the world you're in, it varies. But you're always going to have some sort of moisture in the air. So as the transformer is breathing in and pulling in air from the atmosphere, that breather has a desiccant inside, which I'll show you in future slides, that's going to dry out that air so you don't bring in any excess water from the atmosphere. So again, it contains a silica desiccant that's going to remove that humidity and moisture from that atmospheric air. And then as your oil in the transformer heats up, again under load or increased temperature, the oil is going to expand and it's going to push the dry air out of the conservator tank and through the breather to the atmosphere. And that is called the exhale phase of the transformer. So there's a few different types of transformer breathers. There's a traditional type, which most of you are probably familiar with. The traditional type utilizes a color change of the silica gel and requires constant maintenance. So if you look at the breather on the left of this picture, you'll see that it's an orange color. That's the color that it usually starts out at in the factory when these traditional breathers are built. That the silica gel is dry, and as the transformer inhales and you're bringing moisture in and moisture starts to build up inside of the traditional breather, the color of the desiccant is going to change. So you can see here the one on the right looks a purple-blue color. That means that silica gel is saturated. And what happens when the silica gel is saturated in a traditional breather, it means that it can't take out any additional water. It's completely full of water. So what happens is you have to go out to the transformer. You have to get rid of the silica gel. There's no way to regenerate this type of breather or silica gel. It requires constant supervision and maintenance. You have to replace it. There's no warning signs or alarms other than the visual indication. Somebody has to go out to the substation or the transformer, look and see if it changed from that orange color to that bluish purple color. And of course, there are associated costs with this because you have to replace the silica gel generally every 3 to 6 months. Again, it depends on the region of the world. Sometimes they last more like a year and a half. It really depends where you're located and how much water is in that atmosphere. And you also have to send a crew out to the site to maintain the unit. So they have to dispose of the silica gel, get rid of it. Sometimes there's environmental concerns associated with that, depending on what type of silica gel is inside of there. So again, it's the cost of sending that crew out there, replacing the silica gel, and just the constant maintenance of somebody having to watch it and make sure that it's not saturated and it's not this blue color for a long period of time because it cannot remove any additional water from the atmosphere. Then you have another type of breather, which is called a smart breather. So a smart breather utilizes algorithms to know when the transformer is breathing. So it knows when the transformer is in either an inhale or an exhale phase. And when a transformer is in an exhale phase, there's a heater inside of this type of breather, which I'll show you on a next slide, that will turn on inside of the breather once it hits a certain percent humidity or a certain time. The heater is going to turn on and it's going to condense the water inside of there and it's going to drain out the bottom. So the silica gel constantly regenerates itself. There's no need for anybody to go out there with constant supervision and maintenance and get rid of the silica gel, replace it. You use the same silica gel all of the time. They are equipped with alarms and an internal heater, which I just discussed, that will drive the water off of that silica gel. It doesn't require any additional maintenance. You don't have to replace the silica gel once it's saturated with the moisture. And there are no additional associated costs. So you don't need to replace the gel. You don't need to send the crew out there unless an alarm condition is present. And then they'll know exactly what type of alarm is happening so they know when to fix the breather or when to go check that there's an issue. So how does a smart breather work? So you'll see here on the bottom in the red arrows, again, it brings the atmospheric air into the breather on the inhale phase. It's going to go through that silica gel layer. Once it gets to the point where the silica gel is saturated, either at a percent relative humidity or a time-based threshold, which you can set in our unit, then the internal heater is going to turn on. It's going to condense the water, and the excess moisture is going to follow the other red arrow coming out after the regeneration. So all of the excess water will drain out the bottom of the unit. And again, there's no need to change the silica gel. It will dry the silica gel out, and it can be used multiple times. In a smart breather, you'll see on the left-hand side on the top, you have a sensing block, and that's where your relative humidity sensor is going to be, and that's what's going to tell the breather when it needs to turn on and when it needs to dry out the silica gel and regenerate. There are indication lights, which I mentioned previously. The indication lights will tell the operator, you see here the green light is on. That means the breather is operating fine. There's also yellow and red lights to tell you if it's in a regeneration mode at the time. So that means that the heater is on and it's driving off the water. Or it'll tell you if there's some sort of an error either within the breather or something needs to be checked in the system. There's electronics, and as I discussed, within the electronics, there's a smart algorithm to tell you when your transformer is in an inhale or an exhale phase. So you only want this breather to work during the exhale phase of the transformer, so it's going to push that moisture out as the transformer is exhaling. There's also alarms on this breather again, which I just discussed to let you know if there is an issue. So some of the advantages of a smart breather versus a traditional breather, the initial cost is slightly higher for a smart breather. So the smart breather, the cost is around $2,000. For a traditional breather, it's around $500. I see here on the slide I have it reversed. So a traditional breather is slightly less in cost than a smart breather, but again, you have to send the crew out, you have to replace the desiccant, so there is additional cost later, which is the additional associated costs. So with a smart breather, there is no additional cost. With a traditional breather, again, you have crew time and silica gel replacement. The silica gel on a smart breather is percent RH or time-based. On a traditional breather, again, there is only visual indication. On a traditional breather, there is maintenance every 3 to 6 months. On a smart breather, there is no additional maintenance. There are alarms on a smart breather. It's only visual indication on a traditional breather. And then we'll talk a little bit about condition-based maintenance and what it is. A smart breather can fit into your condition-based maintenance program where you don't have to go out to the transformer all the time. We'll discuss what that means in a next slide. So selecting the right smart breather. The sizing of the breather that you would select is highly dependent on the amount of oil in the system. So the oil in the system is considered the amount in the main tank plus the conservator tank. So the size of the breather also depends on the oil, as we discussed. So the more oil you have, the more silica gel you need in order to dry out that atmospheric air that's being pulled into the transformer. So the larger the transformer, the more oil, the larger size breather you're going to need. And we offer many of different size breathers depending on the size of transformer or equipment that you're installing on. Our algorithm is universal for all applications, which is a little bit different than some other offerings on the market. So you see here that breathers are generally used in tap changers, transformers, shunt reactors, and other industrial uses. Some of the other breathers on the market, you have to specify which piece of equipment you go on because the algorithm is highly dependent on which type of equipment you're installing on. Ours is universal, so it only depends on the amount of oil in that system. Again, it's the main tank plus the conservator. We also have many options available for your installation location. So we have additional options for offshore and harsh environments. So they have stainless steel, they have special gaskets, things like that. And then we also have an additional unit that is for polar execution that goes down to negative 60 C for operation, which is a little bit more expanded than the normal breathers for places like Russia and Canada where it gets extremely cold and it needs to work under very harsh conditions. So there are additional options available too, depending on where you're going to install this breather. So we'll talk a little bit about condition-based maintenance and how this fits into the programs for that. Condition-based maintenance is basically a set of activities that detects changes in the physical condition or equipment. So it's signs of failure in order to carry out the appropriate maintenance or work for maximizing the service life of the equipment without increasing the risk of failure. It's a really long sentence and it's hard to chew on, but basically it's different than time-based maintenance, which is when somebody goes out and has to check the transformer, every 6 months, every year, every whatever the frequency and the pattern is, somebody goes out and checks the equipment from top to bottom to make sure that there's no sign of failure. Condition-based maintenance, you have sensors, you have more a window, everything is online, so you have more of a window into what's happening day to day, minute to minute on your asset and your transformer. So instead of just going out there on a routine schedule like time-based maintenance, condition-based maintenance, you go out there only when something is wrong and you see that there's an issue. So you would define the what you want to measure. So you would have all of these different smart sensors. You would collect all of this data minute by minute, and then it defines your maintenance decisions from that instead of, again, just using the calendar day, going out there and checking everything. So what are the advantages of doing something like that? And this is exactly how the breather fits into this scheme because it's smart. You couldn't do this with a traditional breather. You would have to do time-based maintenance. You would have to send somebody out there. But with our smart breather, it fits into this condition-based monitoring because you can reduce unplanned outages and fines. You know the areas of high risk earlier with online sensors like the smart breather, which are going to continuously regenerate themselves, so you don't have to send somebody out there to look at it all the time. You can service suspected issues sooner before failures occur. And you don't have to waste time on unnecessary maintenance. Again, just going out there and checking a list. I checked this, I did that, when half of the time there's no issue to be seen. It improves asset maximization or lower operational expense. So it saves money when O&M budgets are tight. You only service the assets when needed. And again, there's no unnecessary maintenance or additional crew time. And then there's also safety risks involved, right? So you only want to send crews when it's necessary and they know what specific job and what specific actions they're working on because they see an issue with condition-based maintenance. They don't have to just go out and check every line item on the transformer. And then there's also less time in the truck for your crews, too, driving from station to station because they're only going, again, to specific locations where they know that there's an issue.